Very good day to our lecturer. I am Mekusen Menti, matrix number 70270. We are from Group I. Today we will present for the group project assignment. I will present for the introduction part. For the introduction, this project is about finding an urban region where efficient traffic management is necessary. Quality control and reliability are essential for having a smooth, successful transportation network. Next is by evaluating the quality control and reliability of the traffic flow, we can pinpoint area for improvement and offer strategy to improve traffic management along this route. This is the five distinct time periods that were chosen, which is firstly the morning rush hour, which the time is from 7:30 a.m. to 8:30 a.m., where commuters are traveling to work or school and traffic is expected to be quite congested. The next time period is the off-peak one, which is from 10 a.m. to 11 a.m., where the traffic levels are often lower during this period compared to rush hour time. The third one is the lunch hour, which is from 12:30 p.m. to 1:30 p.m., where commuter may be traveling for lunch or conducting errands and traffic pattern may be different from those. And the fourth one is the off-peak two, which is from 2:30 p.m. to 3:30 p.m. This time period is characterized by lower traffic number, and the last time period is the evening rush hour, which is from 5:30 p.m. to 6:30 p.m., where as commuters head home from work or school, the evening rush hour is marked by heavy traffic. The problem statement for this group assignment are the congestion, delay, and unexpected travel time present difficulty for the flow of traffic along Kuching-Samarhan Road, particularly during peak hours. And next we have negative consequences on the economy and the environment. The objective for this group assignment are firstly, it is to evaluate the traffic flow parameter to get a complete picture of the traffic flow along the route. The next objective is to determine how reliable a journey time is throughout the day. And the last objective is to analyze the effect of different time periods. We'll pass this presentation to the next group member. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and very good evening. My name is Azri Azli bin Azimin, the matrix number of 69198, and for my part, I will be presenting the location of survey. So in this project, the route of the survey was taken place at the Kuching Samaran Highway. This mainly focuses on the vehicles that is traveling from Kuching towards Samarahan. This can be presented by the blue arrow on the picture here, the map here, and the observation point was located at the field nearby the shop lots area, by the shop lots, and it can be presented but on the red area, the red triangle here. So the observation point was selected here because of its strategicness, and it provides optimal visibility for video recording of the traffic flow. As for the methodology section, it will be represented by a process flow diagram. So based on the process flow diagram here, specific timeline of the day that was stated previously in the background is chosen. Then after that, the traffic road, was mentioned and presented previously in the previous slide, was selected, and an strategic observation site selected. Then the traffic flow is recorded by handphone, and it is mainly video recording. And after that, the number of passing vehicles timeline is manually determined. So as for the decision making part, if the survey haven't reached 15 hours yet, therefore the previous actions will be repeated. And if it have reach 15 hours. Therefore, the traffic flow assessment will be conducted based on the types and number of vehicles at the traffic flow. And after that, the number of vehicles and its speed, as time taken, is evaluated. Last but not least, the data analysis uh, will be uh, will be carried out, be conducted using the statistical process tools such as control charts, histogram, and Pareto diagram.
Hello, my name is Daniel. My metric number is 69440, and I will present about the histogram. The first graph or the first histogram graph is the number of car and vans against the hour type. The histogram negatively screw at which the screw data screw to the left. The left screwness, which is negative screwness, indicate the tail of distribution extend to the left, while the right stillness, which is the positive stillness, indicate a tail extending to the right. Even if the first data is relatively high, the majority of data point could be still be lower, resulting in the left skewness. For the second histogram graph, which is the number of lorries and buses against our type, the first data point may be lower than a second, then the remaining data points might be higher value than that contribute to the right straightness of the distribution, as the off-peak one has the highest value among all the value in the data, then it resulting to the right straightness, even though the morning rush value is lower than off-peak one. Even if the first data point is lower than second data, the majority of data points could be still be even lower, resulting in right skewness. Thank you. Okay, for the third histogram graph, the number of motorcycle against our type. The histogram screwed to the left when the last data point is the second highest. It's crucial to consider the overall distribution and the influence of the data points. The shape of a histogram is determined by the distribution of as a whole, include the factor as a sample size, the overall distribution of the data point, and the presence of outlet. Okay, thank you.
Assalamu alaikum and good day. I am Muhammad Haziq bin Sudin with metric number 72743. Is going to present another results and analysis, which is control chart. A control chart is a graphical technique used to study how a process changes over time. This control chart needs some preliminary data, which are the data mean and range, center line, upper control limit and lower control limit. In this control chart, I'm going to divide it into two parts, which are the X bar control chart and the R control chart. In designing a control chart, we need to follow a number of steps. So for step one, we need to determine the cruising speed. In this project, we have determined that the cruising speed, which is labeled as B, is equal to 0.26 kilometer divided by the time taken in hour. So these cruising speeds in 3 different days is tabulated in table 1, which is labeled as the cruising speed of the vehicles during the morning rush hour. So here's the table, which represents the time taken in seconds, in hours, and the days for that speed for a randomly selected sample. Also, we have decided to make 10 subgroups so that our data will be much more accurate and more precise. Step 2 is to find the values of the x bar, the x double bar, the range, and the R bar. How we do this is that the speeds for each subgroup are then averaged to form subgroup average speed, labeled the x bar. And then the grand average of the subgroup average speed, called the x double bar, or in the table it's labeled as the x bar 2, is calculated. And then range is calculated for each subgroup with the formula the range is equal to the highest speed of minus the lowest speed of each of the subgroup. And then the R bar is also calculated by averaging all the subgroups ranges. Therefore, by applying all of the formulas given just now, here's the table 2. So the table 2 shows the x bar, the x bar 2, the range, and the R bar of the cruising speed of the sample used during morning rush hour. And as you can see, the values of the x bar and the range for every subgroup is different due to the variety in the day 1 speeds, the day 2 speeds, and the day 3 speeds. However, it is noted that the x bar 2 and the R bar remains the same values regardless of the values of the speeds of during the each day. Now that we know the values of the important data needed to construct the X bar and the R bar charts, here's the next step, which is to construct a X bar chart. What we need to construct them are the values of the X bar for each subgroup. The center line for X bar chart labeled as CLX is given by the CLX equals to the X double bar. Upper control limit for the X bar chart, the UCLX is given by the UCLX is equal to X double bar plus A2 multiplied with R bar. And the lower control limit for X bar chart, the LCLX, is given by the LCLX is equal to X double bar minus A2 multiplied by the R bar. For example, during the morning rush hour data, so from table 2, the x double bar is equal to 51.98 and the R bar is equal to 24.33. So from the factors for computing central lines and 3 sigma control limits for x, s, and R charts for n equal to 3 because there's only 3 different days. The A2 is equal to 1.023. Therefore, by substituting these values into the UCLX and LCLX, we will get the values of the UCLX equal to 76.88 km per hour and the LCLX is equal to 27.09 km per hour. Meanwhile, in constructing the R chart, the criteria needed is a bit different from constructing the X bar chart. This includes the values of range for each subgroup. The center line for R chart labeled as the CLR is given by the CLR equal to the R bar. Upper control limit for R chart UCLR is given by the UCLR equals to D4 multiplied with the R bar. And the lower control limit for the R chart, the LCLR is given by the LCLR equals to D3 multiplied with the R bar. By using the same example just now, from table 2, the R bar is equal to 24.33. From the factors of computing central lines and 3 sigma control limits for the X, the S, and the R charts, for n equal to 3 just now, D3 is equal to 0 and D4 is equal to 2.574. Therefore, by applying these values into the formula just now, we can obtain the values of the UCLR, which is equal to 62.64 km per hour, and the LCLR is equal to 0. So here is the data tabulation summary after we have applied the formula needed to calculate the data needed for the constructing the X bar chart and the R chart for the morning rush hour. It is noted that regardless of the variety of the values of the X bar and the range, The values of the UCLX, the LCLX, the UCLR, and the LCRR remain consistent throughout the sample number of the subgroups. So here is how the X bar chart would look like for the vehicle speed during the morning rush hour, where the yellow line represents the UCLX, the orange line represents the LCLX, the blue line represents the X bar for each subgroup, and the gray line represents the center line. As you can see, the values of the X bar for each subgroup remains within the control limits. On the other hand, this is how the R chart is represented for the vehicle speed during the morning rush hour, whereby the gray line represents the UCLR, the blue line represents the LCLR, the yellow line represents the range for each subgroup, and the orange line represents the center line. Similar with the X-bar chart, the range values in the subgroup remains within the control limit. It is interesting to note that through calculation in Excel, it is found out that the values of the X bar 2, the R bar, the UCLX, the LCLX, the UCLR, and the LCLR are consistent throughout all the sample subgroups, thus making it easier to summarize them by our types. Therefore, to summarize them, the data are tabulated systematically as shown in Table 4. Another thing to note is that the X bars and the R charts for the remaining hour type are demonstrated in the report. So what are the observations and the findings that we get from the analysis? So from the X bar charts and the R charts of all of the hour types, all data obtained and synthesized are lying within the lower control limit, the LCL, and the upper control limit, the UCL of the charts, and none of them are outside the control limits. These observations indicate that the samples are operating within acceptable boundaries and demonstrating consistent or predictable behavior. Therefore, in summary, if a control chart graph does not exceed the upper or lower control limits, it indicates that the process under observation is within the predicted range of fluctuation and is under control. That is all from our group. Thank you for watching and listening attentively.